So, what are we doing? We're coming out tonight. As John said, my name is Fred Gohsman. I'm going to talk about Unity 3D development, specifically C# development. So, I want to say a little bit about myself and go into a brief history. So, in the beginning, God created what else did you think I was going to say? So, games have been a big part of my life, all my life. And so I want to kind of do a little history of my life based on video games that I grew up with before we get into actual So, the first game console that I ever had was this ATF TV1 model 401. And it came with 4 games. There was tennis, hockey, field hockey. Anyways, they were all a variation of the classic Pong. The important thing about Pong is that this was probably one of the first games to appear on a game console. So this is really the predecessor to modern video. In the late 70s, the early 80s, we started seeing the arcades stand up game systems. Popular ones were Asteroid, Centipede, for me, the fun really started really with this Atari 6400. My uncle got one of these in the early 80s. And the great thing about these, obviously, was that they had a cartridge that you go out, instead of buying the gaming system every time, you could buy an expensive cartridge and plug it in and have a variety of games. Atari offered pretty much the same games that you would have seen on the stand-up arcade, but of course, you could play it from the comfort of your home. So kids today probably think that iPhone was the first mobile gaming device, but back in the 80s, these were a couple of the mobile games that I had. This is a Pac-Man, head-to-head football. We also had an orange basketball, which was a little basketball game. And the graphics were very simple. They weren't as complicated as this high-tech Pac-Man game. They had these little LED lights that would move around the screen, but they were definitely mobile. In grade school, I got introduced to these educational games. And the interesting things about these is they were using the game idea with learning to try to get kids more interested. Some of the games that I remember is Oregon Train and Carmen San Diego and Lemonade Stand. They even made a television show out of this Where in the World is Carmen San Diego for kids. Another interesting genre of games are these puzzle games. Two that I remember really well is Tetris and Millennium. And Tetris, I even tried to recreate Tetris on several different platforms. I ran it on Microsoft's XP Studio when they were still doing that. HTML and JavaScript that run it, and of course Unity. Mario Brothers. Mario Brothers, probably, in my opinion, is one of the most influential movie games that really affected the special genres. And you can see here how it's evolved through the years. Started out as a very simple, pixelated game, moved on to better graphics, and eventually 3D. Does anybody know what the original Mario Brothers was a sequel to?
Donkey Kong?
Donkey Kong, that's right. So, another genre that was fun in the early 80s, 2 games that I remember were Street Fighter and Mortal Kombat. And these were also games you could find on the arcade stand-up arcade as well as Untitled. And I think these games, I'll always remember, certain phrases like finish him and what was it? Sonic Boom. So role-playing games were a big influence in my life. I spent a lot of time playing these games. Some of these games, I actually have at home some boxes, and I meant to bring them in the boxes of some of these games and kind of show that hey, games used to come in a box. We didn't download them all on Steam. The interesting thing about these early role-playing games, so role-playing games were basically a computer version of the classic Dungeons and Dragons put into a computer game. And if you look at this game, it's very similar to those educational games. They've taken kind of a text-based game and then they've slapped on little graphics here and there. And then this game actually had some other graphics that kind of moved around, but it still was more of that text-based. But yeah, mentioning that they used to come in boxes, not only did they used to come in boxes, they used to come with little trinkets with the boxes. So you might have maps, decipher keys, there's little metal tokens sometimes, graph paper so you can graph out the dungeons and stuff. And so here's two examples. On the left here, this is a decipher key that came with Cooler Radiance, and firstly has your console settings. And it literally was a anti-piracy device. It was, they called it protection. It was just protecting them. But it was kind of interesting. You see, there's runes on it, and so they've actually tried to integrate it with the gameplay of the game. The Dungeons and Dragons around, the dwarves had these runes, and I think on the outer ring are the elven runes. And so you get to a point in the game, and they would come up, they'd pop up a message and say, decipher this text. And so you'd have to go to your decipher key and decipher it. And if you didn't, you couldn't continue in the book. Right? So that was their form of piracy protection. And then on the right here, this is actually a cloth map that came with the Ultimate Game, which I thought was pretty cool at the time. It was a good idea because these paper maps that they would give you, you fold them all up, you would take them out, and you fold them up and whatever, and they didn't last very long. But this cloth map, I probably still have somewhere. So here's a screenshot of Final Fantasy 30 years. So you can see where it started out 30 years ago. It was these really small pixelated graphics, and they slowly got better. And eventually we get to 3D, and then today you've got these pretty amazing graphics. So games obviously have come a long ways from their start till today. I gotta mention Elder Scrolls because Elder Scrolls is one of my favorite series. I started playing this way back in the Daggerfall days. And the thing about Elder Scrolls that I found very interesting was the first game that I played that had an open world where you could go around, you could do pretty much anything, and the world just kept going on. It just went on forever, it seemed. And the other thing I always thought was interesting about the Elder Scrolls was they tried to incorporate politics into their game. They didn't always get it right, in my opinion, but it gave me a lot to think about. And someday I'm going to incorporate some of my ideas in politics into the game and try to make it entertaining but still interesting. Civilization. So Civilization was a different type of game, probably one of the first of this 4X jump. They explore, expand, exploit, and exterminate. I spent many sleepless nights in college on the computer lab playing this game. And to its credit, I would say that, so this game it's a turn-based game if you don't know Civilization. And there's not a whole lot of turn-based games, especially now. But it took kind of the concept of a board game and put it into a video game. And I think they did pretty successfully. And it's also also kind of a precursor to the real-time strategy games. And probably the most famous real-time strategy is Warcraft. And you can see Warcraft here. I've got 3 screenshots over the years. And it's kind of the same thing. It's evolved from a 2D game, and now it's kind of more, I guess it's still 2D, but it's definitely the graphics so much better. And that led to eventually World of Warcraft, which is 3D online, which is part of the genre, massively multiplayer online role-playing game. Even the name of the genre is epic. And everything about these games is kind of epic. I mean, they brought the concept of multiplayer into one game where now you've got hundreds or thousands of people all playing one single game at one time. It's kind of amazing. Grand Theft Auto. This game is also kind of, you know, one of these big open world games you go around. The interesting thing to me about Grand Theft Auto is the first game that I've ever played, where you can pretty much just go around, do anything you want, be a complete dick, and there really was never any kind of consequence. You know, you just do what you want and you had fun, enjoyed playing the game. There was a storyline, but if you wanted to stick to it or not, it was really up to you. Another one of my favorites was Assassin's Creed. It's also an action-adventure genre. Again, this was a kind of a little bit less open world, but it was a big world. You kind of do what you want. And there really wasn't much to the concept of the game in my opinion. You just kind of, you were an assassin, so you went around and killed people. So, you know, and it was a little bit more, there was more thought to it. One thing you won't see, I haven't put up here, are these first-person shooting games. I never really get into it, and you could say that this is kind of the same concept, but to me it seems like you're using a little bit more thought, a little bit more ingenuity or whatever. I'll start to shift focus a little bit, so come back to mobile games. So we have Angry Birds came out in 2009. It's kind of a puzzle game. So it's taken the puzzle game and put it on mobile. And obviously hugely successful, and it's kind of, I think, rebooted the mobile gaming kind of field. I gotta mention sports games. So sports games, I think, have started coming a long ways again because of the graphics. I played Tecmo Bowl in high school with some friends. And I always thought that game was kind of cool because, you know, you could choose your own team. They had all the teams from, you know, the NFL in there, and you could even play in season mode where you could play like every week a different team, kind of like a tournament. Now you've got games like Madden where the graphics, you can't even tell that, you know, they're not real people. The graphics are so good. And then we came along. So we, you know, had this concept of Wii Sports and it integrated the sports genre with an interactive game, which is, you know, kind of the next step, I think, in the evolution of games is being more involved with the game. So, you know, we did a really good job with that. Microsoft also had the Kinect in some of their games, which was pretty neat, where they actually had, you know, 2 cameras in this thing, and you can read your movements, so you didn't actually have to have a device to control it. And then PlayStation also had theirs as well, but it just wasn't as successful. Another type of interactive game, this music genre is these games like Dance Dance Revolution, Guitar Hero. There's also like Sing Song, DJ Hero, and Rock Band. But they've also kind of, you know, done the same thing. They've got people more involved in the game by giving you these devices that you play with. The problem with these type of games is that these devices are pretty proprietary to this game. You can't really use the drum set with pretty much anything else. So you definitely have a limited use. They're somewhat maybe expensive for all the devices you use, but they really add a gameplay that's interactive and fun. Which brings me to virtual reality. So virtual reality, you know, it's been talked about for a long time. We're finally starting to see some devices for it, from very simple little cardboard that you can pick up for like $15 to like the Oculus Rift, which is, my price at $600. And Google is going to come out with an Adrian this year as well. So there's some exciting opportunities there. This is definitely a market that I'm going to watch closely and try to get into myself. And if you don't know, the virtual reality is basically, it's a headset and it's 3D, so you feel like you're in the game itself, because when you move, the game moves with you, and you're really immersed into the game. And as you can see, some of the hardware to get into it is cheap. The Google Cardboard and the Samsung Gear VR, they run on your phone, so you already have the hardware you need to play the game. You just need the headset to go on. And then, last but not least, we've got augmented reality. And probably the biggest success so far is Pokemon Go. And some of these devices were quite expensive. Microsoft's got HoloLens, and there was Google Glass, which they stopped supporting. But Pokemon Go has proved that you can do an AR game with just your cell phone. And the concept with AR is that you take the real world and then you kind of transpose your game objects on top of it. So you're playing in the real space, but then you got concepts of your game as well. And with the HoloLens, you're going to have a headset that you wear, and with the Google Glass as well, you have like glasses that you wear, and then kind of augment the game on top of it, or not necessarily games. It's got applications for other games. And then Pokemon is obviously a game, and you see people on their phones walking down the street in the traffic and whatnot, but it's doing the same thing. Worth noting, Pokemon Go was developed on Unity. So that's it for my slideshow about the game. Quick few things about me. Obviously, I'm into playing video games. I'm a hobbyist video gamer. I'm definitely not a professional. I don't have any titles in my book. For a living, I'm a software developer at AFI. And I also organize the Unity User Group here in the Tampa Bay area. And I'll say a little bit more about that later. And just mention that I love to travel. And pretty much all around the world. So a little bit about Unity. First, Unity it's a 3D game engine. So it's an engine developed for games, 3D games specifically, and then they've got, after the thought, they've added on support for 2D, so you can develop 2D or 3D games with Unity. Besides an engine, it's got an editor. It's its own, game development environment that's built on top of this engine and allows you to develop your game that will run on this engine. It's got a built-in physics engine, so you'll see a little bit when I get into the demonstration, some of the physics concepts that you can get basically for free by using their built-in objects and physics engine. It was introduced in 2005 for OS 10, but since then it's now on its 5th major release, and it now supports 21 different platforms, including these ones you see here. And it supports 3 scripting languages, or at least it did in the beginning. Pretty much everybody's doing C# scripting with it now, but there's also Unity script, which is kind of a hybrid of JavaScript, and BooScript, which nobody uses. So
it's their own thing.
yeah, it's just
They got you wrote to.
makes sense. So, and nobody really uses it, but it's there. So you've got options if you want to use it for what you can develop. Games developed in Unity. So here's just a handful of some bigger titles that I thought were developed in it. We've got 2 of the Angry Birds title, Deus Ex, Pokemon Go, like I said, Tiger Woods Golf, Wastelands, what is this? Temple Run, yeah. Hearthstone, Heroes of Warcraft, and one of the Might and Magic games. Also, there's a Kerbal Space Program. Why 2 more written down for this?
Crossing Grid.
What is it?
Crossing Grid.
Crossing Grid. And then hundreds of indie games that have been developed. So Unity isn't the only game in town. There's other 3D game engines. Just to give, the reason I got into Unity is because I'm a C# developer. I can use my existing knowledge of C# for developing games, so that's why we're here. But there are different options for everybody interested in getting the game developed. So we're going to get into the demo now. We're going to have basically we show you a rollerball 3D game. Rollerball actually. This is the game. It's very simple. You're a little ball. You've got a keyboard, up, down, left, right. You can roll around the coins. If you collect them, you get a point. You can see you got a score up there at the top. You hit them. Those little sentences. You got it. You go in here. That's like you basically die. You have one less ball on display. And so the object is to go around and collect all the coins. And if you do it, get a little message saying that you won. And if you don't, you get a message telling you that you're a loser, basically. So let's go ahead and start looking at the game. Alright. So this is the Unity editor. I've already got kind of a base of the game loaded up here. I'm going to change my display. So I've got, the basics of the game. I'm not going to go into too much detail on some of the building. We'll go over the editor really quick. But mostly I'll try to focus on the scripting portion of it, the C# code that I've used to basically tie into it. I'll go over the editor real quick. So we've got a window here. This is called our scene tab. This is basically has all of the components of your game. You can see right here, you can click on them, and they'll be selected. You can move them around in the game. We've got some controls for positioning. We've got some other things. You can rotate stuff around. You notice here when I click this round object right here, it's highlighted. So here, this is our hierarchy tab. So anything that you see in the scene tab, you'll also see in the hierarchy, and more or less vice versa. We can hide things in the hierarchy and they won't show up here. More or less, anything that's here will be here. And also, when you notice when I select an item here, you see some properties show up here. This is our inspector tab. These are basically property sheets for all of the different components of our item. So the hierarchy is made up of all of these different game objects. These game objects have varying things you can do with them. But each game object, let's look at, I've got a couple of empty game objects. So this is your default empty game objects, it's called. And so the thing you'll notice about a game object, all of them will have a transform. This is a component. This is basically telling you the position where it is on the scene. And then you'll have some other things. It's got a name. It's got a tag. I'll go into a little bit more detail about tags. And then a couple other properties and an icon which you can change as well if you want. And then if you want to add additional functionality to your game object, you would add some components. And we've got many components here. I'll go over a few of them, but let me first finish the different tabs. So we've got a game tag here. So this is actually the rendered view of your scene. So in our game, we've got a camera. And so this game tab is actually showing you what's being seen in your camera. And then we've got some controls up here. We've got play control. So right now we're seeing kind of a frozen view of the game. If we push the play, then we actually see the game as it was if you were playing it. And we can actually play it in this game view. And we can also pause it and step through it. Over here we got project tab. So the project tab kind of shows us a hierarchy of all of our assets for the game. So any kind of sound bites we might have, models that we're going to use in our game, some prefabs, materials that we use to put the colors and the textures on models and whatnot. All that stuff we'll find out here in the example. And then we've got a console tab. If we have any error messages come from our game or debugging things that we want to display, that would all show up here. Alright, so I'll go through some of these game objects in our game. So we have some predefined objects for any new game that pretty much are just there as your camera and your directional light. And you can delete them, but they're pretty much needed for all games. So they just give them to you with every new project that you can set up. And then over here you can see, again, we've got a transform object. So that transform object shows us position of where we are. Shows us our rotation. So if we have an object, if you wanted to turn it 90 degrees, you can turn it with the rotation property. And then the scale, this shows basically, you have your object, but if it's too big, we can scale it down or scale it up if we want it larger. And then, because this is a camera, it's got a component on it that tells it how to be a camera. And then the camera component shows us all the properties that we can edit for that. The different game objects will have different components. So the light will have a light component. We've also got an event system. This is basically will handle like button clicks when we have our UI that's those buttons and whatnot. So this will handle our event handlers for that kind of stuff. I've got a blank, an empty game object here that I've called game controller. And this is basically where I put some of the logic that controls our game as we go through. Since right now we'll be adding a script to it in a little bit. I've got an object here. It's just an empty game object that I have. It's called spawn point because this is where when our ball falls out of bounds, this is where we'll bring our ball back to. This will be where we respawn our ball. I've got this platform. This platform I just put together in Blender. Blender is a 3D open source free modeling tool, and you can kind of quickly develop some models in it. I'm not very good at it, but I was able to put this together. You can see it's just got it's got like a little plane here. That's our ground. It's got some holes here. The holes are made up of two parts. It's got a wall and then a little ground piece. And this ground piece is where, like, if the ball falls in there, we're going to capture that and then say, hey, you got it, and then reset it. And then we just got an outside wall here that prevents the ball from falling off again. So let's go ahead and start wiring some of this up with some scripts. I've already defined all the scripts, so I'm going to be boring you guys writing it out, but I'll show you what the scripts are doing and how they kind of work with the game. So the first thing we'll do is we've got our game controller, and I'm just going to drag the game controller script onto it. And so, first thing I want to know is that a script in Unity is a component, just like any other component. And actually, probably behind the scenes, all components are a script, but the default ones are compiled into the DLLs with Unity. So you don't actually see their code. But all of our custom scripts, they'll show up here. They say they're a script. They have the script tag. You can actually double click on this guy, and it'll bring up our editor. If I single click, it shows right here where that guy actually resides in our assets. And then it'll show you some properties for the script. So this particular script, I've got a half dozen more properties defined here. These first three are sounds, so they're just audio clips that I've defined. And I set those back to none. You can see here it tells you there's none defined, but the type we're expecting is an audio clip. So if I go to my sounds folder, I've got a few audio clips. I can just drag one of these on there and populate that property with the audio. So I've got a sound here for when you win, I've got a sound here for when you die, and then I've got a sound here for when you've collected a coin.
How did you build those assets? What did you use to build those assets?
The sounds, I downloaded off the internet.
Okay, so you just
I just went to a free sounds site that had different sounds, and I just found some that I liked.
So you could record them.
You could definitely record them. Unity doesn't have like built-in support, but there might be third-party tools you can get. But if you have an audio tool that you know, you can just record your own sounds. These are different formats. One of these is a wave, other two of them I think are RPGs or something. So it supports a variety of different formats. So I've got a property here called I've got a property here that type of game object, and it's called spawn point. And I'm just going to set that to the spawn point of game object that I created, and I can just set that by dragging it in there. And it shows you here that my spawn point name of my game object that I dragged in there. So if you look at the spawn point, I mentioned earlier that you can change this little icon. So I'd set the spawn point to the circle, so you can even see in our game controller that shows that little circle that represents that game object. We don't have a player object yet, but when we do, I'll drag that into this space. We've got a starting ball count. You can see by default it was set to 2. Our coins to win was set to 10. And we've got a scoreboard. This is actually a script object, but later on I've got a pretty fab that I'll show you. A script object that will figure out those two objects together. So let's go ahead and take a look at this script. So Unity supports 2 code environments that I know. The newest one being Visual Studio, and it's supported on and developed, I think, from the beginning. I'm using Visual Studio here as more like Visual Studio. And I just should fire this up before we start. So this will take a second to come up. It'll create its own project for this. But otherwise, it's just using those scripts from that assets folder that we saw. So it's gone out, and it's identified anything that's a script, and then it's brought it into the project. And so you can see your entire list of scripts here. can see the game controller out here. So these scripts are literally, they're C# classes. I've defined them in namespaces, that it's not required because I like to have namespaces in my code. When I develop professionally, I like to have them in my game code as well. So I'll start at the top. Just like any C# script, we've got using statements to include namespaces that we want to reference. I'm referencing an enum namespace that I've got one object defined in there. This Unity engine namespace is kind of the default base root namespace for Unity. The majority of the objects, the components that you're going to use in Unity will be defined in this namespace. And then I'm also including a scene management namespace for managing the transition from scenes. First, I'll show that you notice that all game scripts that are attached as a component to a game object inherit from mono behavior. And mono behavior basically gives you the default functionality of any kind of object in Unity. So to give you access to the game object that your script is a component of, it'll also give you some method for getting access to other game objects and other components on the game object, which I'll show you a little bit in a little bit, but that's very important. And then something I forgot to mention before is we got a required component, and it says it's of type audio source. And when I drag that game controller script down here, it also added this audio source component here. And so basically my script, I said, hey, this is a required component. I need this component for this script. So by putting this required component attribute on this class, it was smart enough to say, hey, it's not there, let's add it to the game object. So that we know that. So here are some public properties. And you'll notice that these public properties have the same name as those properties we saw in the editor sheet in the inspector. And so Unity basically just exposes all your public properties of your script as properties that you can edit. So if you want to have just a property that you use internally, you can make it private. If you want to have one that you expose, you make it public. And you can see that that wind sound I showed you, when it came up, I didn't have anything there. It said it was some type audio clip. And you can see here, yes, indeed, it's type audio clip. And spawn point was a game object. You can see here, literally, it's a type of game object. And then our starting ball count, it had a value of 2 because I defined it as 2 default value. You can go and edit it in the editor, and it'll remember that. So we can set that to anything we wanted. Just because we set it to the default here, the editor will remember what we've changed it to. We've got the scoreboard that the script we'll look at later. I've got a couple of private variables, that audio source that I said was required. That's basically going to play our sounds. Then I've got a rigid body. We'll talk about that a little bit more. We've got a current ball count. So our starting ball count is, kind of the maximum number of balls you could have. Our current ball count is, how many do you still have? If you died, you recommend you lose them. And the points collected is how many coins you collected so far. Points to win is basically how many coins you need to collect before you complete. And then I've got a reference here to a game state object, and this is the enum that I mentioned. So I really threw this in here to kind of show that in C# we use enums a lot. Well, in Unity, we can use pretty much anything that we do in C#, including enums. So the way I'm using this enum is I made it static so that you can access it pretty much anywhere in your game. So any script that we want to know, is this game running or is it paused, we can just check this game state object. So by default, I'm going to set it to not started, because when the game starts up, it's not running yet. We don't want the other scripts to be running until we're ready. So let's get into a little bit more of the code. first thing you'll notice is we've got a start method. And the start method is one of these predefined kind of methods that Unity will auto hook up for you. So it's got like 20 different event handlers. And so you can define a method, and if you get a right signature, the event handler will automatically be wired up, and that method will handle that event. And one of those events is start. And start will run whenever the script is activated. So if the script is part of a game object that is active when your game starts, it'll run at the beginning of your game. If that game object is activated at a later point, then the start method will happen at that point. The start method kind of gives you a way to do some initialization in your script before you start doing other stuff. And a really useful thing to do in your start method is this right here, is get component. So in my game controller, I want to be able to make use of my audio source. If I try to get a reference to it every time I go to use it, it's a little bit of an expensive operation. So I'm going to do it once in my start method, and then I'm just going to hold on to that reference for the rest of the script. So whenever I want to play my audio clip, I just have that reference that I can call. And get component is one of these predefined methods that monotone behavior gives us. And then what that does is it looks at the game object that your script is a component of, and it looks for other components of the type that's defined that exist on that game object. So, go back to Unity real quick, that will get this. So it's on the same game object, it's another component of this type. And then I'm doing the same thing. I'm going to get a rigid body component of the player object. So that's a separate object. That's why I created a reference to it up here to the player, so that I can get its rigid body. And then later on, we'll interact with that. And then I've got some initialization stuff. When I first start the game, I'm going to set my ball count to the total number of balls, with a point count to 0. And then I got a debug statement here that I just put in here. These are the statements that I said that would show up here in this console window as we're playing the game. We'll see some of these debug statements that'll just pop up here. And then here I've got an if statement. I'm checking the scoreboard. If it's not equal to null, then we're going to call a method of the scoreboard script. And the reason I put a null check on this is I'm actually going to play the game a couple of times for you guys before I ever put that scoreboard script on there, so I don't want it to crash. But this is generally a good idea if you think that there's going to be a game object that might not be defined. If you don't want your game to crash, you want to do a null check just so that your game can keep playing without having problems. And then once we've done all of our initialization, then we're going to set our game state to actually playing. I got a few other methods in here that kind of are part of the overall gameplay. I've got restart method, and this is real simple. When the game is over, there's a button that popped up, and it says, play again. So all that does is calls this restart method. You notice that this start method wasn't private. There's no identifier, access modifier here. So by default, it's private. This restart method is public, and that's because I want to call it from outside code. And then all that's doing, it's gonna load a scene. It's gonna load the first scene in my scene hierarchy. There's only one scene in my game, so it's always gonna be the first scene. So basically, restart's just gonna reload, start the scene, put all the points back on, and get either restart the start script and start from scratch. I've got a method here where my player falls off the board, called the player die. So whenever the player falls off the board, this method will be called. The first thing it does is it's going to play a sound, and and I'm telling it which song to play. It's the dice song. And I've just got a little method down at the bottom that will handle that. Then it'll check our ball count. If our current ball count is 0 or less, it should never be less. But if it is, then game over. So I debug it, game's over. I'm going to set the game state to game over. I'm going to set the player to be inactive. And what that means is that I'm not actually deleting the player from the scene, but I'm going to hide him, and I'm going to stop any controls that were defined. So we're going to have movement controls on that player. They won't be able to control him anymore. But they'll still be there. I'm going to set it to him later. And then again, I'll check on the scoreboard. If I have a scoreboard defined, then I'm going to show a dialogue that says that you're a loser. If we're not out of the ball, then we're going to do something else. We're going to respawn the player, and so we're going to check, hey, is our spawn point defined? And if so, then we're going to look at the transform property. So I said all game objects have this transform component defined on them, and then those transform components have these properties. So Unity's kind of gone ahead and gave us this transform property for free. We didn't have to say get component from the transform. They just given it to us because all game objects have this component on them. And so it gives us a quick way to access the position. I can set the position. What I've done is I use that spawn point, put it in the position where I want the ball to start. And so I just set the position of our players transforming to that position. And then I'll just put it over there. And then here's where I use that rigid body. Because my ball is going to be moving when I respawn him, I don't want him moving because he may already be heading for out of bounds pocket. So I'm just going to set his velocity back to 0 so that he's not moving when he respawns. And I'm going to document our ball count, and then if I've got a scoreboard, I'm going to display updated ball count on the scoreboard. So let's go ahead and let's add our player. So if I want to add game objects in Unity, I've got this hierarchy window. There's a couple of ways to do everything in the Unity editor. But the quick and easy way to do this is to just right click and then I hit a context menu. And you'll see things like create empty. I'll show you some empty objects that I've used as well. Particularly, we're going to use a 3D object, so these are the predefined 3D objects in Unity. And I'm going to use a sphere. And I'm just going to, you can see here, sphere is added to our hierarchy. You see its inspector, it's got some predefined properties and components to it. I'm just going to rename this real quick, and I can do that just by clicking on it, or I can hit F2. I'm just going to call this ball, because that's going to be our ball. Real quick, first, so Unity's funny sometimes, it likes to put things in random positions, so we just reset this transform, we're going to set it to 0, 0, 0. And I'm just going to set this to the same position where our spawn point was, and it was -5y, so that's actually going to move that up. See here, let's move it up. So the ball has a scale of 1 to 5. So that means it's 1 unit big. The center of our ball is where this position is. So if we want the ball to sit right on the surface, we need to set the y to half. So half the ball will be below where it was. And then we set our z to -13, because that's where our spawn point is. I'm going to go, so Unity has materials. There's 2 types of materials. The first type is basically going to allow you to define a texture or a color. And what it uses, it's got some different properties. We're just going to use this albedo property. I've got a predefined material here. I've set it to blue. And I'm just going to use that. I can just do that by dragging it on to the object itself. You'll see it showed up here, or I could have just dragged it down here, just like any other method. So that paintball, you can see it here. I'm not going to go into material component. There's a lot around there. We'll see, show you real quick some of the other components that were predefined on our sphere. So we've got a mesh that basically just kind of shows you the wall. That's kind of your 3D model of the wall. We've got a sphere plan. So game development, whenever you want to know two objects interact with each other, that concept's called collision. So we've got a collider that tells us our collision detection. So we've got a collider, so the ball and we glide with. And then the mesh render basically is what's kind of showing you the ball itself. If you hide that, the ball's still there, it's in the scene, you can move it around, but you can't see it. It's invisible. So for the ball, I'm going to add some movement to the ball so that when I use my arrow keys or my WSD, I can move the ball up and down where I want. So I created a movement strip. I'm just going to drag that out to this guy. And it's only got one property, and that property is force. And basically just the amount of force that's going to be applied to the ball when I push one of the arrow keys. If I push the on force, that's going to go in that direction. So this movement strip, it's pretty straightforward. It's pretty short. It's got a rubber variable for force. It's got a rigid body. For start method, we're doing the same thing. We're going to get that rigid body component. We're going to set it to a variable. And then we've got another one of these methods that if you define it, it will handle an event in either event. And so the update event, this is an event that is fired every frame of the game. So you can set a maximum frame rate for your game, something like 60 frames per second. And optimally, you would fire this method 60 times a second. But if your game starts slowing down because there's too much processing going on, there's too much going on in the computer, it's going to skip frames. And it's going to try to catch up. But this update will only be run when it actually renders it. So this is the spot where we basically do our animation and our input detection. And that's exactly what I mean. The first thing I do is detecting if there's input, specifically if there's input from these predefined axes. So Unity's got these things as known axes. Basically, there's a horizontal axis that goes to the horizon, and those that are by default tied to either the A and D key on the keyboard or the left right arrow buttons on the keyboard, or on a game controller, there would be your joysticks left and right position. And then there's a vertical axis that we can also check, and as you can guess, that's your up and down, your up arrow, down arrow, up on the game controller, down on the game controller. So when you get those, and the values that are returned from those are a float in the range of -1 to 1. And if you're not really pushing any button or pressing any control joystick, it's going to be 0. And if it's to the left, it's going to be -1. If it's to the right, it's going to be 1. Maybe I think backwards, but that's basically what it is. So you're going to get a value between -1 and 1. And then with that, I'm going to determine our direction. And our direction is a vector 3. And vector 3 is simply a structure that has 3 points in it. It's got your x, your y, and your z coordinates. And so in this game, we have our ball moving, up and down, which is going to be our z. And then we've got our right and left, which is going to be our x coordinate. and then physically, you know, up like this and down would be our Y. But because our ball is moving around on the surface, we're not actually going to move in the Y direction. You could have like a bumper or something that pushed your ball up, then we might, but for this particular case, we don't. So we're setting our Y to 0, we're setting our X to horizontal movement, and our Z. And then we're going to use a method on a rigid body. It's called add force, and it just like it sounds like it's going to add some force, some physics effect to that object. And the force is basically the direction you want to move it times the amount of force that you want to put it on. That's exactly what I'm doing here, is I'm multiplying the direction by the amount of force you want to put on it. And so that's going to make our ball move. So the next thing I want to do is I want to make a platform spin. I want it to rotate, so there's a little bit more interest going on and make it a little bit harder. So I defined a spin script, and I'm just going to drag that out into our platform. And you can see here, I've got 4 defined properties on here. So I've got a speed. This is basically just how fast it's going to spin. I've defined 1 is basically kind of a nice slow speed, and you'll see that the platform will spin at that. Later on, I'm going to add points, and they're also going to spin. And I'm going to use this exact same script. I'm going to set the speed to like 5 so they spin a little bit faster. And then you see these other 3 properties. So for the platform, I want it, the Y, like I said, the Y's are up. I want it to spin around like this. So it's going to spin around that Y axis. So I'm going to set this check mark for the Y axis, and this will spin around that axis. So let's take a look at the script. It's another real simple script. Those 4 properties we looked at. I've also got something that I call the speed modifier. I put this in here because I wanted 1 to be a nice slow speed, but I didn't want it to be too slow. And if I just used 1 as the value, it was a little bit too slow. So I used the speed modifier to set it to the exact speed that I want, my lowest number that I want to use. Then I'm using the update method. I'm not checking for input this time, but I want to do an animation, so I want it to update every frame. So I'm using the update method. And then here I'm using that game state emu property that I talked about earlier. I'm checking. If we're playing, then we want to do the animation. If we're not playing, we don't want to do the animation. So we're just going to exit this method altogether if we're not in that playing state. Then I go, I check. I do just, a Boolean operation. I say, if x-axis is true, then we're going to set a variable called x rotation to our speed times our speed multiplier. If x-axis is false, then we're just going to set that x rotation to 0. I'm just using that conditional operator here to do that. Same thing for our y-axis and our z-axis. And then again, I'm using a vector 3. And then I'm assigning that to those 3 axes. And I'm multiplying that by something called delta time. So I said that update is executed once per frame, but not necessarily at any fixed interval. But we really want our animations to kind of progress at kind of a fixed interval. If our game slows down or speeds up, if we don't, it'll be kind of choppy. So Unity gives us this thing called delta time, which is literally the difference between the last time update method was called. So this just gives us a way to smooth out our animations to keep it kind of more consistent. And then again, I'm going to use the transform. This time I'm going to just use the game object that we're connected to, the transform, and then I'm going to call this rotate method. And this rotate method is corresponds to this rotation property, and it's basically it takes in that vector 3, and so it's going to update these values by each of those. And it'll just rotate that. One thing I wanted to point out about scripts in Unity And scripts in .NET development in general is you want to use kind of the single responsibility principle, right? We want our scripts to do just one thing, and we want to do it well. We don't want our scripts to be this huge conglomeration of different functions. And so you'll see, you won't necessarily see on this tutorial, but in like a real game, an object like a ball object or a platform object might have a half a dozen different scripts, each doing a different aspect of the game. And we do that so that we can make these reusable. For example, the spin script, we use this exact same script on our coins later on, and I'm just going to configure it a little bit differently, and it'll act differently, but it'll be the same simple script used for different scenarios. Alright, so let's test this out real quick. So I push the play button up here, and it should render down here. It's ready to play, and I've got an error. So you can see this error pops up down here. It'll also show in the console here. So if you make a mistake, this is a good way to figure out what you did. So this is telling me that I need to assign game controller to something. Yes, so in the game controller, I said we have a player property, so I need to assign a ball to that player property. And then, alright, so now you see the platform spinning because of the spin script. And if I move, you can see that the ball moves. Now, if I fall in the hole, nothing happens because I haven't wired up the functionality. Let's go ahead and do that. So my platform, I've got this, it's an empty game object. It's got a script on it, but then it's got all of these different levels that I've defined. So under all of these holes, I've got a whole floor property. So what I'm going to do is I'm just going to select all of these whole floors, and I'm going to drag our out of bounds detection script onto those. And that requires a game controller, so I'll drag our game controller onto that. And this says game controller, and it looks like it's the game controller game object. But really what it's looking for is the game controller script. And by dragging the game object onto it, it's smart enough to know that this is the game object and this is the script on that game object there. The out of bounds controller, I'm going to be real quick on some of the rest of these because I'm running long on time. But this out of bounds script is basically is using a different event handler method for predefined event. This one's called, actually, this one is using on-collision enter. There's two of them here that I wanted to show just for comparison. They're very similar, they work slightly different. But this one, because I've got a collider on the floor, and I've got a collider on the ball, when those two come in contact, it'll fire this on-collision enter event. There's three collision events. There's on-collision enter, which happens the first time they come in contact. There's an on-collision exit, which happens as soon as they stop coming in contact. And then there's an on-collision stay, which happens once per frame the entire time they're in contact with each other. And so you can write methods and handle each of those events. And so I've handled the on-collision enter. It has a collision property assigned to it, and on that it has a collider, which gives me basically access to the game object that we collided with. And what I'm doing is I'm going to check its tag. I'll show you in a minute how we set the tag, but all game objects can have a tag assigned to them. And so I'm saying that my player object is going to have a tag called player on it. And I'm going to check, did I collide with the player? If so, we're going to do some functionality. If not, we're just going to ignore that collision. And then what I do is I call out to that game controller and I call that play diagram exactly what I said earlier. And then I let the game controller handle what happens after that. We don't want this script to have to know too much about the game. We want it to be generic, so we're just going to call out somebody else and let them do it. I won't talk about the trigger entry because I've got it in another script I'll talk about. So that gives us basically our collision detection. And let's go ahead. So I said that it's checking that for a tag. So I go to my ball, I've got a tag property here I can set. Player is one of the predefined tags, but I can also create custom tags by clicking that add tag, and I can create anything I want. And since we said this one was going to be tag player, I'm just going to tag that so that that'll actually detect that. I've got an empty game object here called coin. And what I'm going to do here is I'm just going to create a coin. I've got a predefined coin here in my prefix folder. So Unity gives you a way to create some composite game objects, put different components on, customize how you want it. And then all you have to do is drag them down into the assets folder, and it creates what's called a prefab. And that's just a game object that you can drag back into your hierarchy, and it has all that stuff defined for you. So you don't have to go and redefine it from scratch. And so I've got one here called coin. So I'm just going to drag that into my empty game object coin. And you can see that shows up here, the scene view as well as the game view. And you look over here, we've got some stuff going on. It's got a collider, it's got its render, just like the sphere did. It's got its rigid body. It's got a script here defined. It's called spin that we've already looked at. And like I said, I can configure this differently. So I'm going to make this one spin faster. So I've set it to speed 5. And this one I'm going to have spin just in all 3 directions. So I've set all 3 of the axes. It's also got a collectible script on it. And that collectible script needs reference to the game controller. So I'm just going to drag that onto there. And we'll look at this. So what this is when the ball collides with the coin, I want to collect that coin. So for the coin, I did something different. For the collider, I've got an is trigger property, and I set that is trigger property. So what that means is that the ball will actually physically will go through that other game object. It can pass right through it, but a trigger event will be fired. With the collision, when the ball falls on the floor, I didn't have the is triggered set. So the ball will actually go and fall on the floor and it'll stay there because I didn't set it is triggered. The is triggered event won't be fired because I didn't set it up as a trigger, but the is collision event will fire. So that was what the difference was between those is triggered and those on-trigger enter and on-collision enter. So the on-trigger enter works very similar to that on-collision enter. It gets a collider where the on-collision had a collision, which had a property. That was the collider. This just gives us the collider. And again, it gives us reference to the game object that we're colliding with. I can check for its tag. If it's the player, then I'm going to do some stuff. If it's not, I'm just going to ignore it. And in this case, I'm going to call a method on the game controller called coin collected, which we looked at. And then I'm going to destroy that game object. And the difference between destroying a game object and setting it inactive is that the destroy will actually physically remove it from the scene. It won't just hide it, and it'll free the resources that it has. So if you're creating game objects on the fly and like bad guys or something, and you add a bunch of bad guys, and then as you kill them, take them off, you want to destroy them and free up those resources. Because if you just hide them, they're going to keep eating resources. And as you keep adding more guys to it, they're all going to keep using the resources. So in some cases, like this, it's good to just destroy the object. Alright, so now we've got a game. I can follow in the hole. It'll show you that it'll reset your guy here. You'll lose a player. You fall in 3 times, the game will be over. There's no visual indication of that going on. So I've got another pre-defined game object called scoreboard, which I'm just going to drag on here. It's got a label that says balls, and then it's got a label that shows how many balls, same for the score. And then it's got a couple of little pop-up messages for when you win, when you lose, and a button here that you can use to start over. And for this, I'm just going to try to run through this real quick. So my scoreboard's got a scoreboard script that I'm just going to drag it on here. And it's got a bunch of properties. So it's got a bunch of properties, ball text, which is this object is this thing right here. We'll click on right here. So we can see in our game that this object here. So I'll just drag that onto that script. So we have to reference that in our script, so we can update that value. Then the same thing for score. And then I've got some predefined game objects here. This is just this whole game over thing. And then I've got a you win and a you lose game object. I just drag one in here. And then we've got a restart button. Earlier I mentioned this event system. I said this is going to be used for the UI. If we have a button click, we need this event system to handle that. And so that's kind of right here. Our button's got a non-click event that we can have. We can add different methods to that. So I can just set this object to our game controller, and then from our game controller, I can select the restart method that we saw earlier. And so now I should be able to start this. This should start we had reference to the scoreboard script in our game controller. I forgot to drag it on there. So we just do that. We drag our scoreboard game object, and then look at the reference to that scoreboard script. And so in my start method on the game controller script, I had a method that basically said reset the scoreboard, and that's what would hide those things by default. What I didn't do was set our coins to win to 1. So I'll do that. The neat thing about Unity is I can do it while the game is playing in our game view. I can update these properties real time, and they'll update the game. So I can use that to configure things and tweak it to like just how I want it. Important thing to remember though is that once you exit the game, those will reset to what they were before. So you need to remember them and then you'll set them once you exit the game. And now that I set it to 1, I should be able to go in here. Win. And I can restart and see how our bounce detector works and the ball player. And what was that last one? That's it. That's pretty much all there is to intro and work with. Two last things I'd like to mention. If you want to know more about Unity, the Unity website is here, unitypurity.com. We've got a lot of great resources. You can download Unity Editor. It is free for basically, for personal use, it's free, and if you're a business, you're like under a certain site, it's also free. So they actually do their best to make it so that people can get anything development. So you can, like I said, you can download the editor. There's tons of tutorials, and you'll even go to this tutorial site, you'll see a similar rollerball tutorial to the one that I did. It's a little bit different, but it's very useful. And there's also YouTube videos of people who walk you through the tutorials that we have all on the site as well. There's also a Unity community forum that you can go to at unityuser.com/unity. And recently there's started the Unity Slack community. And so you can go to unityslackers.slack.com to sign up for that. One of the members has created unityslackers.com. So you can go in there and basically enter your email address, I think, and your name, and it'll go into a Google form and it'll give you access to the Slack community, to the Slack team. And then, as I mentioned before, I do organize the Tampa area Unity User Group. We have a website at meetup.com/unitypurity. We do have a Slack channel on that Slack community. It's UNIG-Tampa. And so once you get on the Slack community, you can join any of those Slack channels you'd like. If you want to join ours. We have meetings basically twice a month. We have a workshop that has always been on Mondays, so I call it the Monday workshop. The next one is next Monday on the 10th, and these happen at the Agile Thought offices at Rocky Point. They start, I think, at the same time at 7 o'clock. We have some time for networking and a little bit of pizza, and then we're going to a presentation. And next Monday's presentation is on Unity multi-purpose avatar, and that's basically a way of doing modeling with characters in Unity. It's super interesting. We've got a couple from Lakeland that have a small development company, game company. They're going to represent Laura and Dennis. They'll be presenting on that. They're building an MMO, and they're using UMA for their air project. So that should be very interesting. And then also, we have a Saturday meetup that also happens once a month. And the next one is October 15th, and those are held in Clearwater, and probably changing the location for that, but that will be happening this month. So enjoy it. And if you guys do Unity development and you'd like to show off what you're doing, either one of those meetups is a great forum to show what you're working on. People are always interested to see what you're working on and to share. Hopefully, we'll get our HoloLens from our office and we'll show that off at one of the but there's always somebody who's got like their Samsung Gear VR and showing. We got a couple people, Mark here included, who's done some VR games, and so